Hello, Mr. Goulet, and in this video I'm going to teach the core ideas behind basic trigonometry, and some of them include radians versus degrees, special right triangles, the unit circle, and how trigonometry functions like sine, cosine, and tangent actually connect together. And by the end of this video, you should understand how all these concepts connect instead of just memorizing formulas. Okay, so I'm sorry for the sudden screen change, but let's talk about the three main trigonometry functions. So sine, cosine, and tangent. And the best way to remember them is the words SOHCAHTOA. And what it means is sine of theta equals sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the main angle we use in formulas is theta. So this is this symbol, and it represents the angle. So if you want to find, for example, the sine of theta, I'm gonna take the opposite side and divide it by the hypotenuse. For cosine, I'm gonna use adjacent side to the closest side to the angle, and do it over and put it over hypotenuse. It's the same thing for tangent. So for example, let's do a quick example. So if we have a triangle right here with the sides of 2, 3, and 5, and we need to find the sine of theta. Sine means opposite over hypotenuse. So in this case, the opposite of theta would be 3, and the hypotenuse would be 5. So our ratio would be 3 over 5. Okay, so trigonometry also depends on the Pythagorean theorem, and for the formula for that is a squared plus b squared equals c squared. So this formula only works for right triangles, so if the one angle is 90 degrees. Okay, so for example, the shorter legs are called, the shorter sides, like B and A, are called legs, and the longest is called the hypotenuse. So for example, if we have a shorter legs with the value of 3 and 4, how we find the hypotenuse? We would use this formula. Therefore, a squared would be, it doesn't matter in what sequence it goes. So 3 squared plus 4 squared is going to equal to 5 squared. And then in order to find c by itself, you would need to square root. So square root of 5 to the power of 2 is just 5. So this relationship basically appears constantly in trigonometry, and it's crucial to master. So in addition to Pythagorean theorem, there's also special right triangles. And these triangles are also important because their side lengths always follow predictable patterns that are very important to remember. So first, 45, 45, 90 triangle. So since both angles are equal, which is the ratio of 45, both legs are equal to. So the ratio is 1 to square root of 2. So both legs are the value of 1, and the hypotenuse is square root of 2. So for example, if both legs are the value of 1, the hypotenuse is going to be square root of 2. So if the legs were, for example, 5, then the hypotenuse will be 5 root of 2. So yeah, basically that's the pattern. And this triangle helps us find exact trigonometry values without any calculators. The second triangle I'm going to go over is 30, 60, and 90 triangle. So the side ratio is 1 to square root of 3 and 2. The shorter side will always lie the opposite of 30-degree angle. So if the shorter side is, for example, 4, then the hypotenuse is going to be 8, because it's going to be like x. This is going to be 2x, and then this is going to be x squared root of 3. And if we have an x of 4, therefore 2 times 4 is 8, and then we're just going to substitute 4 instead of x, so it's going to be 4 square root of 3. Okay, so another thing I want to go over is people usually measure angles in degrees. So for example, 90 degrees, 180 degrees, or 360 degrees. But in higher math like calculus and college algebra, radians are more useful. So radians measure angles based on the radius of a circle instead of dividing a circle into 360 pieces. So common measurements would be 360 degrees is 2 pi, 180 degrees is just pi, and then 90 degrees is pi over 2. But how did I actually come up with this? So in order to get the radian value, you would need to take the degree multiplied by pi over 180. So for example, let's convert 90 degrees. So radians equals, instead of degree, put 90 multiplied by pi over 180. And then this is just a simple algebraic equation. 90 and 180 is going to be canceling out. There's going to be 2, there's going to be 1. And if you multiply 1 by something, you're just going to have to write something. So it's going to equal to pi over 2. But this also works the other way around. So let's convert from radians to degrees. So if you need the degree value, you would need to put a radian multiplied by 180 over pi. So just the reverse of this. So for example, let's find 180 degrees. So what you would do is 180 degrees equals pi, because this is the radian value of 180. You're going to multiply it by 180 over pi, and this is just going to cancel out, and you're going to get 180 degrees. Okay, now we connect everything together with the unit circle. So the unit circle is a circle with the radius of 1 centered at the origin. Origin is the center of the circle. This is where trigonometry becomes visual instead of just formulas, and you can actually see how do we implement what we learned in real world. So every point on the unit circle has coordinates of x and y every single time. And all these coordinates directly relate to trigonometry functions. So cosine is going to equal to x coordinate, and sine is going to equal to y coordinate. So the unit circle is also divided in 4 quadrants. So in quadrant 1, both x and y are positive. Right here, both x and y are positive. In quadrant 2, x is negative and y is positive. Quadrant 3, both are negative, so x is negative and y is negative. Quadrant 4 is x is positive and x is positive, and then y is negative. And all of these quadrants are dividing circle to 90 degrees. So from 0 to 90 would be the first quadrant. From 90 to 180 is going to be second quadrant. From 180 to 70 is going to be third quadrant. And then from 270 to 360, or in our case 0, is going to be the fourth quadrant. So there are also reciprocal trigonometry functions, which are called cosecant, secant, and cotangent. Each of those is the reversible of the others. So let me explain to you. So cosecant is 1 over sine. So cosecant is essentially the reverse of sine. And if we remember that sine is opposite of our hypotenuse, the reverse of that would be hypotenuse over opposite. In secant is the reverse of cosine. And as we remember, cosine is adjacent over hypotenuse, then secant is going to be hypotenuse over adjacent. And consequently, cotangent also follows the same strategy. So cotangent is the reverse of tangent. Therefore, if you remember that tangent is opposite over adjacent, cotangent is going to be adjacent over opposite. And so to summarize my lesson, I created a cheat sheet. You can go back in the video and check if you understand every single one of them. So the first thing is SOHCAHTOA, as we remember. It helps define the main trigonometry functions. There's also radians and degrees, and there are 2 ways to measure angles. Special right triangles also help us find exact values, and you should have it memorized. And the unit circle connects these all concepts visually. I really hope this lesson helps explain not just how trigonometry works, but why it works. Thank you for watching.